Hello folks, today we're going to go over our lesson on spheres and cylinders, and let's go ahead and get started because I don't want to take too long on this stuff. So real quick, you probably already got this in the mail, but being geometry first period, we are now relegated to these time slots right here and here. So my live Webex meetings will be at 10 on Mondays and Wednesdays. My pre-cals will be on Tuesday and Thursdays with these time slots here. Okay, so moving on. Today, again, I just mentioned we're going to study spheres, with that hemispheres, and then part 2 video is going to be on cylinders. Let's get started. So a sphere is basically a set of all points that are equidistant from a central point in three-dimensional Euclidean space. And the key part of this for our intent, we're going to cut out, of course, because of the accelerated, we're already accelerated block, and then we take out several weeks. We're way behind. We're going to cut out some of the things that we would have done with non-Euclidean geometry on the sphere. So this is going to be my radius right here, and this is going to be our principal dimension. So when we're working our problems, we only have one dimension to worry about, and that's going to be the radius. Of course, diameter, we could give you the diameter, but you're just going to cut that in half and take the radius. And I have some definitions for you. You could look at these at your leisure. You could pause and look at them. But again, I just mentioned what a sphere was and a radius was, and diameter, we would just cut it all the way through. Great circles, because we're not getting into the non-Euclidean applications and some of the things we could do with that. There's some interesting triangle properties on a circle. Basically, it's basically the circle with the center of the sphere as the center of the circle as well. Okay, hemisphere, you're just slicing that grapefruit in half. That's all you're doing. Okay, moving on. So when we talk about finding the exact and approximate surface area and volume of the sphere, there's no lateral surface area that you're going to learn about in cylinders and prisms and stuff. There's just surface area. And what is not on your formula charts is hemispheres. Well, hemisphere is half of a sphere, so the surface area will have a lateral and total surface area, so you got to watch out for that. So like for instance, when you have a hemisphere like this, you're going to have the surface area of this half right here plus the part that you just cut open. That's going to be a circle. So your total surface area for a hemisphere, a hemi, is 3 pi r squared. Okay, it's the 2 pi r squared, which is half this, plus the pi r squared of the circle. Okay, all right. And that was just getting a little off topic, but I'll talk about that some more. I'll erase all this. And what we're asked to find is the surface area and volume of this sphere with radius of 5. So all we do is just plug in 5 right here and 5 right here. So that's just going to be 4 pi 5 squared. That's 25 times 4, which is equal to 100 pi. This is exact. Okay, and this is surface area. So approximate, you're going to put this puppy in the calculator, and I already did that. And it's going to come out to be 314, of course, 3.1415927, so on. Is going to be 314.159 meters squared. Okay. Volume is just 4/3 pi radius, which is 5, cubed. Well, that's 5 times 5 times 5, which is 125, right? I should grab my calculator. And then you're going to multiply it by 4 and divide by 3. And I'm punching that into my machine right now. And that's going to be times 4 divided by 3 is 166.7 pi. And if I were to multiply that by pi, I messed that up in the calculator. It'll be a bigger number. I didn't put that in my calculator here, but just put that in the calculator and you got it. Alrighty, so volume. Oh, wait a second. We're finding the radius of the sphere. So basically, spheres is just plug and play formulas. It doesn't make it very interesting for high school work. It's more middle schoolish if we just told you to find the surface area. But here we're going to find the surface area. We're given the surface area and we're going to find the radius. First thing you want to do is write down your formula. So 4 pi r squared is equal to 24 pi. And you're going to solve for r. That means you're going to get rid of the pi. You could get rid of that right off the bat. You have 1 on each side. You're going to divide by 4. Well, 4 in the 24 is nothing more than 6. So you're going to have r squared is equal to 6. So r is equal to the square root of 6. Then you're going to plug that into finding volume because we already knew the area. And it's going to be 4/3. You look on your formula chart until you get it memorized. And then we're going to do root 6 cubed. And that's what I did right here. I just put that in the calculator. Got 61.7. 6 centimeters cubed. All right, moving on. Yippee-yay. So surface area of Hemi is a radius of 3 feet. Well, surface area, and this is going to imply total surface area, all right? So we got to do the surface area of half the hemisphere. Remember, a full surface area of a sphere is 4 pi r squared. Cut that in half, and this is 2 pi r squared. The Hemi is pi r squared. So, the circle's pi r squared. So total surface area is nothing more than 3 pi r squared. Well, we plug that 3 right there. 3 pi times 3 squared. That's 9 times 3 is 27 pi. Okay? And it didn't say find the approximate, so I'm just going to leave it like that. So that's going to be feet squared. All right. If you want to find the approximate, you just put pi in the calculator, but there's no reason to if you don't have to require it. This one is the hardest of the bunch. Find the radius of a sphere with a volume of 288 pi. So pay attention on this one. First thing you want to do is write your formula down. 4/3 pi r cubed. Well, that's simply equal to 288 pi. First thing you can do is get rid of the pi's. Those annoy you. Then to get rid of a fraction, you're just going to multiply by its reciprocal on both sides. So you're dividing by 4 and multiplying by 3. I did that in the handy dandy calculator, and I got an r is equal to 6. Okay? And that's all you're looking for. If they ask for surface area, you plug that back into the formula. Okie dokie, and I think this is our last one. What is the volume of a Hemi with a radius of 6? Well, the formula for a sphere is 4/3 pi r cubed, and you're taking half the volume, so you're going to multiply this by 1/2. All right, well, 4/2 is just 2, so we have volume of a Hemi is 2/3 pi r cubed. All right, well, we just plug 6 in right there, toss it in our handy dandy calculator. 2/3 pi times 6 cubed, that's 216. 216 divided by 3 times 2 gives me 144 pi. Okay, and that's going to be inches cubed. All right, it didn't say exact or approximate, so I'm too lazy to put this in the calculator, so I just leave my answer like that. And I think that's it. I will do cylinders next. Okie dokie.